We are a team of breeders and scientists that have come together to make a positive step towards net zero in sheep farming. This is Breed for Change. Together, we're developing tools that will help us breed better suited sheep, that will reduce the carbon footprint of lamb and make sheep farming sustainable.
So at the real heart of the Breed for Change project is collecting performance data on the sheep and then using it to develop tools that we need to actually breed sheep that produce a really high quality product, leaving a profit for the farmer, but are also climate friendly.
This project is being funded by DEFRA through Innovate UK and involves 10 different breeding partners across the supply chain, giving us a really strong and collaborative approach.
Innovate UK are proud to have funded the Breed for Change project because of its science-led approach to create the tools that British sheep farmers really need. We're all working hard to meet net zero targets, and it's great to see the tools the consortium are developing through their tight collaboration, helping positive change in the sector.
We bring the sheep off forage for a short period before measuring them, and all the sheep that we measure together are managed together, so that we can really pull apart the genetic differences. We make sure that each group includes an even representation of sires to avoid bias. We weigh the sheep. We use the portable accumulation chamber trailer to measure the gas emissions from grazing sheep. We take them up the ramp. Lambs go into the chambers for a period of about 50 minutes. Once they're in the chambers, we monitor the levels of carbon dioxide, oxygen and methane, and then we can use that to pull out genetic differences in the amount of methane that individual lambs are producing. We've done many of these pack measurements all over the UK, capturing information from thousands of lambs on about 40 different farms. So we've been working closely with research groups in New Zealand and in Ireland in developing the technology for measuring methane so that we have internationally aligned protocols. So what we're finding so far is we see a tremendous amount of variation in the amount of methane lambs produce, even if they've been managed in exactly the same way from birth to the point of time when we measure them.
So we're also measuring feed efficiency on farm. We bring the sheep into the unit and we feed them ad libitum grass nuts. So this is automatically measured by the equipment that we've got in here. So we know that some animals can eat 15 or maybe even 30% less feed and grow at the same rate as others. So understanding these efficiencies and comparing them with other traits we're interested in is important for identifying relationships and also the trade-offs between feed efficiency and other performance traits. We're also taking CT scans of sheep through our mobile CT scanner, and this enables us to measure rumen volume. We're focusing on the reticulorumen, so the reticulum plus the rumen. The low methane emission sheep have smaller rumens, and the reason we're doing this is that it's important to understand body composition, so that any changes that we make due to our breeding in production or methane traits, they won't have unintended consequences on the sheep's ability to thrive on the pasture. And because we're sharing this data with other global research groups, it's helping us to get more meaningful results out of that data that we collect on this project. Another thing we're doing is collecting rumen fluid from the animals to study the microbiomes, because research shows that the balance of these microorganisms or bugs may influence how much methane the sheep are producing.
We're breeding and studying several different breeds of sheep for this project, looking and focusing on the Innovis maternal breeds. We're developing tools to rank breeding animals on their ability to reduce the flock's carbon footprint. So to do this, we take tissue samples from the sheep, and this means we have their DNA profiles, which gives us more accurate measures of the animal's breeding potential for certain traits, such as weights, longevity, muscle and fat depth, and we're combining them with new traits that we're looking at in the project, such as their methane, their feed efficiency. We put all of these different traits into a selection index. This is crucial because this will drive the efficiency, and using this breeding tool to be able to aid farmers' breeding decisions, it can be used to reduce the carbon footprint of the flock whilst increasing that profitability potential. So the project will make available its findings for providers of carbon calculators, and hopefully that will be able to be used to refine models and subsequent decision-making tools.
Breed for Change is helping our farmers be more competitive on that global stage. We're doing this really for the whole sheep industry, for nature and for the animals involved. We still have more work to do, but you can take advantage of the work that we've been doing. Go to the website and be part of the change.